Okay, so I'm going to talk about my project 3, final project for big data. And for this, we are going to be using the sample supplies from MongoDB and performing our data analysis on the JSON structure and format. So first, let's see what's on our list. So first, we need to connect MongoDB on VS Code, export as JSON, import JSON, and then do everything else in our notebook, which is pre-processing, exploratory data analysis, queries, and articles, and finally make a report. So let's get right into it. So, okay, let's go to our VS Code. Okay, so first, before anything, we need to set up our MongoDB uh, cluster, and which I've already done, which is this one here. And we want to connect this to our VS Code so that we can have this. I've already done it, but I'm showing this as a demonstration. So what do? We need the connection string. So we go to connect and then MongoDB for VS Code. Here we copy our MongoDB connection string. We go here and connect it here. And as for the password, you just type in your password and you should be good to go after doing this. I've already done it, but I will not, and so I will not do it again. In the end, you will get to this. So you have sample supplies and sales, and you have all your documents in here. So this is one thing. So another thing to do is we want the JSON file of this to import it into our notebook and perform our analysis on that. So for that, I'm going to go into my terminal. So here, I've already exported it, but I will do it again one more time. So let's go into our final projects. So first, we're going to be using the Mongo export um, command, which is over here. So this is the command. So let's try writing it from the beginning. So um, Mongo export URI is equal to, this is going to be our connection string, which is this one. Let's copy it here. And then as for the password, I'll just type in my password here because there's no harm in it. Okay. And then after this, we want to be able to, we will need to put our database name, which is going to be sample supplies. And then collection is going to be sales, because here sample supplies and sales. And then out is just going to be whatever name that we want, and which is this one. So basically this is good to go. So let's copy that, put it into our terminal, and then let's name this JSON supplies 2, because I already have done it. So let's see how it goes. It should work. Connected to MongoDB. All right. Now it's getting our 5,000 records, and there we go. We have it. And if we take a look at it now, here we have our JSON supplies 2. So that is how we connect and use Mongo export. Now we're going to be importing it, and let's look at our IPYNB. So here, import pandas, and then we're going to be loading our JSON file into our data frame by using the pd.read JSON, and it is in the same directory, so it's done. So if we look at sales dataframe.head, we have this, which is basically very interesting because this is a JSON structure. So let's go deeper into it. So first, if you pay attention to it, you can see that the items here are stored as an array. And if we didn't pay attention to it, let's see. Okay, so these are two separate records. If you take a look at it, the items here are an array of dictionaries. So first we have laptop, and inside of, and this is one object. So here we have laptop name, tags, price, quantity, etc. And then next we have another item, envelope, right? We have envelope, price, and then next we have printer paper. So there's a lot happening over here, and this is why we exploded. So here before it would be like just laptop, and then next is printer paper. But after exploding it, let's see our head. Now we have laptop, envelopes, and printer paper recorded separately for the same ID. They have the same ID, but exploded. Now, so basically those three items are now stored as different records. As you can see, there's no more square bracket at all. This one is exploded into these three, and so on. And that is the first step towards understanding our JSON structure for the rest of our analysis. And that is pre-processing and possibly even EDA done. Talk about JSON explode with examples. Yes, I have already done that. We'll see more in details very soon. So step one, query one, show top 10 products by sales. So first we need to get the product name, of course. And how do we get the product name? The name of the products are in items. So let's see. We need to get the product name from the items dictionary. The product name is nested in a dictionary, and we are going to be using the lambda function to extract it. Basically, what we need to do is we need to be able to access the value of name within the items dictionary. So extract it, and then we access it using the lambda function. Basically, this how do I say this? The apply function is used to apply a custom function to each element in the items column, and it is the result of this operation is a new series, is a new column called product name that contains the extracted product names corresponding to each row in the data frame. And yes, so it's much simpler if I go into the head. So let's see the columns. Now we have a new column called product name. And as you can see, the product name is the name extracted from the items. So laptop, laptop, envelopes, envelopes. Perfect. And then after that, top products is equal to sales dot our product name, count value, and it will take the top 10 and reset our index. And I renamed the columns, and then we have product name count, and this is our top products. Okay, so wait, top 10, all right. Query 2, show top 3 products, sales by store, look by location. So now we need new metrics for sales. And how do you calculate sales? You multiply it by, let's take a look at this, quantity and price. But you cannot just do it because the quantity and price are stored in here. So we need to be able to extract the quantity and price from the items dictionary. So if we go to our notepad here again, you can see quantity and price. They are all stored in the items. So we've exploded it, and now we want to access the quantity, the value of quantity, and price. So we do that simply by applying the lambda function again. So sales df sales, new column, sales df on the items, we apply this whole function, this whole lambda function, which is going to be taking the quantity and multiplying it by the price. And that is how we get our sales. So if we take a look at it again, dot columns, we have a new column called sales. Previously, it was just up to product name. And now here we have calculated the sales correctly. And based on that, we can now group our group by store location. And yeah, and we sum the sales, and then we get our top 3 products by store. Again, we use the lambda function here, dot sum, and then reset index in the end. And after that, we group them by store location, and then we rank them by sales for each store location. Next, we filter the top 3 products for each store location because we want top 3. And then in the end, we have Austin. We have 3 top selling items for Austin, which is backpack, laptop, pants. Basically, everything is just backpack, laptop, pants, the top 3. So for Austin, Denver, London, we have top 3. New York, San Diego, Seattle. And this is it for our query 2. Query 3 is show rankings of each store. This is basically straightforward because we have already calculated the sales. So we just group by the store location sales dot sum. And then we rank the store location by sales, and then we sort them by rank. And in the end, we get Denver generating the highest sales with this amount, and San Diego being the least with 672,000 at rank 6 being the lowest. And yeah. Next is going to be query 4, show methods purchased by gender in a table. Again, we need to extract. Okay, so gender, where is gender stored? if we take a look, gender is stored in the customer. So same thing with the lambda function. We extract the gender from the customer dictionaries, and we do it using the lambda function. So we create a new column called gender, CLCF customer, apply our custom lambda function x.get gender, and now we have a new column called gender. Next, for the table part, as because we want it as a table like here, I will be using the pd.crossTab function, and it will be gender and purchase method. And I renamed the index name to be gender, and then I print it, and as a result, we get this. Um, I did some more pre-processing because in the guidelines it's showing only online and in-store. So yeah, I dropped phone, and then I renamed F to female and M to male, rename it to gender for better readability, and this is our final result for query 4. Query 5, show monthly total sales. This is a bit tricky because we're using datetime, but no worries. So first we need to know where the date is stored. So date is stored here. This is what we want, but it is stored in the sale date dictionaries. So extract the value of date from sale date dictionaries, and we access using the lambda function. So we create a new column called sales date, sales df sale date, which is basically this one, and then we apply the lambda function. We get the date, and then doing there we do pd.to date time, so that it is in the date time format, datetime data type, and then in our if we look at our columns now, we have another column called sales date, which we get as a result from this. And yep, here we get our sales date. Perfect. And after that, it's not done yet because we want to extract the month and year from the sales date and create a new column. So we create yet another column called sales df, which is a more refined version of this, and we're going to be using dt dot date time dot to period, and then using m for month. And yep, basically that is it. We'll have our year, month, and after that we group by year, month, and then sum the sales for each month, rename the columns for clarity, better readability, and we print, and this is our result. So this is for query 5. And as for the final report, I did some more exploratory data analysis. And first is the unique tags, like the category of all the category of products they are selling. And if we take a look at that, it is general, school, stationery, office, electronics, kids, writing, travel, organization. So as you can see, this is mainly, you could say that you could get a hint that this is mainly targeted towards students and offices, etc. So that is one hint. And then the monthly sales here, I visualized it to see if there's any pattern, but this is what we get as a result. Pretty messy, it's hard to read, sort of. And it is really, really, really fluctuating. I don't see any pattern here. So I try to see if there's any seasonal trend happening around here. So I plotted it for every 4 months. I changed it, just this one from the previous code, and this is what I get. And still, there's not much of a seasonal trend going on here as far as I'm concerned. But one thing that I found interesting is that in 2013 January, 2015 January, and 2017 January, those were the times where the sales were the highest. So yeah, that is one clueful insight that we could look up upon. And in the end, I have my report, which is a detailed summary of what I have found and some of my conclusions I have made from my data analysis. You can take a read, and yes, that is pretty much it for my project. So here I have worked with a sample database from MongoDB and performed the entire data analysis in using the JSON format and not CSV. So this is it for my project presentation. Thank you.